Today we're going to look at creating simultaneous equations. So it's not that I'm just going to give you some simultaneous equations to solve. You're actually going to have to obtain them to start with and then solve them. So a slightly harder skill again because yeah, we've got to actually do the creating. Okay, let's jump straight into an example. And what I want you to do, I'm going to do 4 examples and I'm going to focus on the creating. But what I really want you to do is before each one, pause the video and see if you can create a very similar equation yourself. It might be that you use a different letter to represent the number of rabbits or whatever, but it should still look very similar. So please do that. Otherwise, I'm going to talk through these without really pausing, but you can rewind or fast forward as you need to. Okay, first one. There are some rabbits and chickens in a field. I'm going to label the rabbits, the number of rabbits that is, as R, and the number of chickens as C. Together they have 65 heads and 192 feet. How many rabbits are there? How many chickens are there? So I've got some information, 2 numbers, and I want to work out what R is and what C is. Well, rabbits have 1 head and chickens have 1 head. So it must be that the number of rabbits plus the number of chickens equals the total number of heads. That's my first equation. Um, and then I need to think about feet. So rabbits have 4 feet, and so the total number of rabbit feet is going to be 4R. Chickens have 2 feet, so the total number of chicken feet is going to be 2 lots of C. And then if I add those together, that will give me the total number of feet, and that will be 192. And this is my first set of simultaneous equations that I've created. Again, I'm not going to solve these now. I will make a separate video that solves it if you're unsure. But the answer is then R equals 31 and C equals 34. Okay, on to the second example. 1,000 tickets were sold. Adult tickets cost £8.50, children's cost £4.50, and a total of 7,300 was collected. How many tickets of each kind were sold? In some sense, this one's a bit nicer because I've not had to realise about the number of heads a rabbit has and the number of feet a chicken has and so forth. Okay, they told me how much a ticket costs, but I still have to create the equation. So I'm going to say that the number of adult tickets sold is A, and the number of children's tickets sold is C. And that's going to mean A plus C equals 1,000. Then the total amount of money I get from my adult tickets is going to be £8.50 multiplied by the number of adults tickets that I sold. I'm just going to write this as 8.5. It's the same as £8.50. It's just I've turned it into sort of a more mathematical decimal problem. There's no need to put the 0 there. You can if you want. And then how much are we going to make from selling the children's tickets? Well, each one is £4.50. So if I sold 2, it would be £4.50 times 2. But I've sold C, so it's £4.50 or 4.5 times C. And then the total amount raised is 7,300. And I've created another 2 simultaneous equations which I can solve. This time I don't have integers in both of the throughout all the equations. You're going to have to think about how to deal with that. I'm not going to talk about that right now. But what you should get is that 700 adult tickets were sold and 300 children tickets were sold. Okay, example 3. Amy has more money than Fred. If Amy gave Fred £20, they would have the same amount. Well, if Fred gave Amy £22, Amy would then have twice as much as Fred. Quite a lot going on here that we need to decipher. How much does each one actually have? So we're going to say that Amy has A amount of money and Fred has F amount of money. And we know that A is going to be greater than F. Probably not going to use that, but I'm just going to write that down. Okay, now if Amy gave Fred £20, they would have the same amount. So that means I'm going to take £20 away from Amy and I'm going to add £20 to what Fred has. And then that will mean they have the same amount, so I can say they are equal. So that is my first simultaneous equation. If Fred gave Amy £22, so suddenly Amy gets £22 and Fred loses £22, then, sorry, I put the equal sign in already. Amy would have twice as much as Fred. So they're not actually equal. I would have to multiply what Fred has left by 2, and Amy will then have that amount. And that is, again, simultaneous equations. It's slightly different. We've got brackets, we've got numbers on both sides, but it's the same idea. We can then rearrange and solve. And I want you to have a go at doing that. I'll go through it in a bit. But the answer is that Amy has £146, Fred has £106. Last one. Calculate the numerical value of the area of this triangle. Wow. So we've got an algebraic expressions throughout. And then we need to calculate the area. That does not mean that we multiply this algebra out. It means we have to set up some simultaneous equations, solve them, and get the sides, and then get the area. Okay, the crucial thing is this rectangle bit. I know that this length is the same as this length. So I can straight away write down that 3a minus b minus 1 equals a plus b. And I've got an equation. Then I know that these two are also equal. I use 2 little dashes this time. I shouldn't use 1 dash because that would mean that they're also the same as these, which is not necessarily the case. But I can then write down that 3a plus 1 equals 2b plus 2a minus 1. And again, I've set up simultaneous equations, two equations, 2 unknowns, which I can then solve. If you do so, you're going to have to do some rearranging first. You should get that a is 3, b is 2.5, base is 10, height is 5.5, because you have to substitute a and b back in to here, and you multiply these to get an area of 55. That's it. There's 4 examples illustrate how you can create equations. It can be quite complicated, and then once you've created them, you might have to do a few extra steps to be able to solve them, but it's just rearranging equations. I'm gonna make another video that goes through solving these equations if you weren't sure how to get the answers. Otherwise, I want you to practice this some more. Hi, this is just a bonus video going through these 4 questions to actually solve the simultaneous equations if you couldn't remember how to do it, or if some of the later ones you were unsure about. Okay, let's do this. So we've got simultaneous equations, we've got different coefficients. So the first thing I am going to do on this first one is multiply both sides of the top equation by 2, because that's going to make me have 2c up here. So I'm going to get that 2r plus 2c is equal to 130. And then I'm actually going to, I've decided I'm going to write above it the first equation. Remember, you can write them in either order, and sometimes it just turns out to be advantageous to do it the other way around. The reason I've done this is that I've spotted that this number is bigger than this number, and 4r is bigger than 2r. So now, because the signs are the same, I'm going to subtract them, and I'm going to get that 2r is equal to 62. And that's going to give me r equals 31, which is our first answer. We can then substitute it back in, can put 31 in here. I would put it back into one of the original ones, it's just a bit simpler. Okay, so then I can do 65 minus 31, and that's going to give me c is 34, and I've done the first one. Brilliant. Second one, we've got our simultaneous equations. Oof, this time we've got non-integer coefficients. Right, well, there's 2 things I could do. I could multiply through by 2 to get integer coefficients. I'd get 9a plus, sorry, not 9, I'd get 17a plus 9a equals 14,600. And then it would be a very similar, I mean, it'd be larger numbers, but it'd be a similar thing to question 1. do you know what? I'm not going to worry about that. I'm just going to roll with the decimals and see what happens. So I'm going to multiply both sides of this equation by 4.5. Nothing wrong with me doing that. And that's going to give me 4.5a plus 4.5c. Hopefully you can now see why I chose 4.5. And that's going to equal 4,500. Really helps that this is 1,000 here because I can do that in my head, no problem. Okay, so I'm sort of going to, this equation's sort of out of it now. I'm just going to put a dotted line through it. Actually, it's still there, but I'm not going to be using it. And now I've got my simultaneous equations with the same coefficients. They're a nice way around, so I'm going to subtract them. And I'm going to get that 4a, these are going to cancel, equals 2,800. I can divide through by 4. 28 divided by 4 is 7, so 2,800 divided by 4 is 700. And I would then return to this first equation because it is the simplest one. C is going to equal 1,000 minus 700, which is 300, and I've solved my second simultaneous equation. Third one. All right, let's do this. Oof, doesn't look nice, does it? Okay, the first thing I am going to do is, actually I'm going to create a little bit more space. I'm going to delete this. Sorry, I didn't anticipate how much room I'd need when I solve it. Okay. First thing I'm going to do is just rearrange these equations to make them a little bit nicer. So the first one, I'm going to minus f from both sides, and I'm going to add 20 onto both sides. So I'm going to get a minus f equals 40. I've just rearranged this equation. And then the next one, okay, before I rearrange it, I'm going to expand it out. So it's going to be a plus 22 equals 2f minus 44 by expanding my brackets. And then I'm going to rearrange this one. I'm going to minus 2f from both sides. Okay, a minus 2f, and then I'm going to minus 22 from both sides. Actually, I'm going to get minus 66. Negative here. This is looking slightly awkward, but we can, because of these negatives, but we can still deal with it. I've got a and a here, so I'm going to subtract these, and I'm going to subtract the right-hand sides, therefore. The a's are going to cancel. I'm going to get minus f minus 2f. This is a double negative, so it becomes minus f plus 2f, and I'm just going to get an f here. And then I'm going to do 40 minus 66, which is the same as 40 plus 66, and I'm going to get 106. Fred has 106 pounds. I can then substitute back in. Which one is the best one to substitute back into? I think I'll substitute back into this top one here. So I've got the a minus 106 is 40. So now I can add 106 to both sides, and I'm going to get that Amy has 146 pounds. Brilliant. Bit more involved, you can see, but we've created the simultaneous equations. We've used our knowledge of expanding brackets, rearranging. We've turned it into something that we know how to deal with. Yes, there's negatives, carefully subtracted, and we get the correct answers. Last one. Quite a lot going on here. Again, it's not like the standard format that we've been used to, because I've got unknowns on both sides, so I need to be able to deal with this first. Right, let's do this. Okay, first equation, I'm going to minus a from both sides, and I'm going to minus b from both sides. I think I'll take it I'm going to take it step by step. I'm going to get 2a minus 2b minus 1 equals 0. Yeah, just minus a from both sides, minus b from both sides. It's gone from the right hand side, and it's cancelled partially here, and it's just become more negative. I can then add 1 to both sides, and that's going to be my first nicely set up simultaneous equation. So I basically dealt with this one and turned it into this. I'm then going to take the second equation and do the same sort of thing. Okay, so I'm just going to put a little box. I'm going to put a little box around this one because this is the key one I'm going to use in a minute. I think to save space, I am going to write the next one just on the right hand side. So what I'm going to do is for this one I'm going to minus 2b and I'm going to minus 2a from both sides. So that's going to give me a minus 2b plus 1 equals minus 1. To finish this off, I'm going to write a minus 2b equals minus 2. I've subtracted 1 from both sides, and again I've got it into this nice form. What I'm then going to do is I'm going to basically write them beneath one another, just like I did before. Okay, so actually I'm going to move it to here. And now we're in a good place. I've got minus 2b and a minus 2b, so I am going to subtract them. Quite a lot going on in this problem, but you know, this is the sort of problem you can face. We get 2a minus a is going to give me a, minus 2b minus 2b is going to cancel. Okay, so because they're both negatives, I still subtract the equations and these cancel. And I've got 1 minus 2, and that's going to give me 3. I get quite a nice number. Brilliant. What shall I put it back into? Don't know actually. I think I'll put it back into this one. So I can write that 3 minus 2b is equal to minus 2. I can rearrange this. I'm going to add 2 to both sides to give me 5 minus 2b equals 0. So 5 equals 2b, so b is equal to 2.5. I'm not quite done though because it's asked me for the area of the rectangle, so I'm then going to need to work out the sides. But I can do that quite quickly. For this one it's a plus b, so it's going to be 3 plus 2.5. It's going to be 5.5. I could just check that it works here, that I get 5.5, and I will get that as well. And then I'd probably pick this top one, so it would be 3a plus 1 is going to be 3 times 3, which is 9, plus 1, this one's going to be 10. Again, I can check it and get 10 here, and then I'm going to multiply these two together. 10 times 5.5 equals 55. Wowzers, quite a lot going on there, but we've created and solved simultaneous equations, applied it to this rectangle. I hope that makes sense. What a great topic.